To demonstrate polymorphism and overloading, let's look at a class that represents a dog. First, I'll create a new project. Now I'll create my dog class inside of a package. File new package. We'll call it poly for polymorphism. And then I'll create my dog class. So this class represents a dog. The first thing I'm going to do in this class is define some static variables. These are going to be used to store hard-coded default values to be used in some of my methods. So, static variables. The first one will be the default name for a dog. So it'll be static string. I'll name it default underscore name, all uppercase, and I'll set it to generic dog. Using one of my constructors, I'll be able to create a dog without providing a name. I'll use this default name to name the dog. Default name for a dog. The next one will be the default age for a dog. Static double, and we'll name it default underscore age, and I'm going to set it to 0.5 years. Again, I'll be able to create a dog without providing a specific age for the dog. I'll use this default value. Default age for a dog. Then I'll create a default weight value. Static double default weight, and we'll set that to 1.75 pounds. If I create a dog and I don't provide a weight, I'll use this as the default weight. Default weight for a dog. Then I'll have some other static values. Default food for the dog to eat. Static string default food. And we'll set that to a string generic dog food. This is default food for dog to eat. And then a default sound for the dog to make, a default bark sound. Static string default bark. And that'll just be a generic bark exclamation. Default sound for dog to make. Then I'll have a default number of times for the dog to bark. Static int default num times bark. We'll set that to once. So by default, a dog will bark just once. Default number of times for dog to bark. One final static variable. When a dog eats, it's going to gain weight. So I'm going to create a constant weight gain increase percentage value to multiply by. Static. It'll be a double. And we'll name it weight gain increase. I'm going to set it to 0.01. That's 1%. Let's also make this final, meaning I can't change it later on in my code. Constant weight gain value. Now let's create some instance variables for our dog class. Every dog will have a name. Name of dog. Every dog will have an age. Age of dog. Every dog will have an owner. That'll be a string. Owner of dog. And finally, every dog will have a weight. Weight of dog. Now let's create the constructors for the dog class. This class will actually have 3 different constructors, meaning overloaded constructors. And this will provide us with 3 different ways of creating a dog. Constructors. The first constructor we write is actually going to do most of the work in setting up a dog. Public dog. The arguments will be a name for the dog, an age for the dog, an owner for the dog, and a weight. So this creates a dog with given name, age, owner, and weight. This is name of dog, age of dog, owner of dog, and weight of dog. Inside of this constructor, we're just going to set the instance variables in the class. So this dot name equals the given name. This dot age equals the given age. This dot owner equals the given owner. And this dot weight equals the given weight. So when we create a dog, we can call this constructor and provide a name, age, owner, and weight. Now let's create another constructor, meaning let's overload this constructor and provide another way of creating a dog. So here I'm going to overload my constructor, meaning same name but different arguments. In this case, string name and double age. So if I create a dog using this constructor, I only need to provide a name and an age. This creates a dog with given name and age. This is name of dog, age of dog. In this constructor, I'm just going to call the first constructor, which does all of the work in setting up the dog. To call the other constructor, I'm going to use this, and then I'm going to pass the given name, given age, null for owner. I'm looking at these arguments here. Name, age, owner will be null. And then for weight, I'm going to pass the default weight value that I've defined as a static variable. Dog dot default weight. Call first constructor with 2 given values and 2 default values. Now I'm going to create a third constructor, meaning I'm going to overload the constructor again. So same name, but different arguments. In this case, no arguments. In this third constructor, I'm going to call the second constructor with 2 arguments. To call another constructor, I use this, and I'm going to use the default name and the default age. Dog.default name and dog.default age. So this calls second constructor with 2 default values. And this, we could say, creates a generic dog. Now let's create some methods in the dog class. The first method is going to be an eat method. This will allow the dog to eat a given amount of a given food. Public double, it's going to return a value, given amount of a given food as a string. So dog eats given amount of given food, the amount of food to eat, and it's going to return the dog's new weight after it calculates it. First thing this method is going to do is just print a message, system.out.println print line. We'll say this dot name, which is the dog's name, is eating given amount of the given food. What we're going to do is calculate the weight gain, add the weight gain to the dog's current weight, and then return the dog's new weight. So to calculate the weight gained, create a variable, call it weight gained, and it's going to be the given amount multiplied by our weight gain increase percentage value. So dog weight gain increase, that was 1% multiplied by the given amount. That's going to be the weight gain. Calculate weight gain. And we'll add that to the dog's current weight. This dot weight, add the weight gained value, add weight to current weight, and then return the new weight. Now we're going to overload the method, meaning we're going to create another method with the same name, but different parameters. So we'll start by creating the method the same way, public double eat. This will only have one parameter, and that's the given amount of food to eat, but it won't accept a specific type of food to eat. This method will actually force the dog to eat the given amount of generic dog food, and we're going to use our static variable default food. So this will call the first version of eat method with given amount and default dog food. So we're going to call the other version of eat with the given amount, and then we're going to use the hard-coded default food variable to call the other version of the eat method, and then we can return the result of that from this method. Dog eats given amount of generic dog food, amount of food, and return the new weight. So what's happening here? This version of the eat method is overloading the other version of the eat method. It has the same name but a different number of parameters. In this version, it takes the given amount of food to eat, and in the body of this method, we're calling the other eat method, and as the first argument, we're using the given amount, and as the second argument, we're using the static variable specifying generic dog food. In this, we're allowing the first version of the eat method to do most of the work. Calculate the weight gain, add the weight to the current weight, return the new weight, and in this second version of the eat method, we're calling the first version of the eat method with specific arguments. This allows a dog to eat in a different way. Now let's overload eat again by creating a third version of the eat method. In this version of the eat method, we're going to have a single argument amount, but as a string. So we're overloading the method in that we have the same method name, and the single argument has a different data type. In this version of the eat method, dog eats given amount of food, and since the given amount is a string, we're going to parse it as a double. So parses given amount as a double amount to eat, and still going to return the new weight. So all this method is going to do is parse the given amount as a double, and then call one of the other versions of the eat method. So let's do that. The first thing I want to do is define a variable, a double that I can use as a return value. Double return val. We'll set it to 0.0 by default. And then we're going to parse the given amount as a double. Double amount as double equals, using the double class, there's a static variable, parse double. I'm going to use the given amount, as the argument to parse. So this is parse given amount as a double. And then I'm going to call another version of the eat method with this argument. So we'll say amount as double. Which version of the eat method? It's going to call the version of the eat method that takes a single argument as a double. So that's this version. So call second version of eat method with amount as double. We're also going to get the return value from the other version of the eat method. So let's go ahead and reset our return val variable that we've defined here. I'll show you in a second why we're actually doing it like this. So and gets return value. At the bottom of our method, we're going to return this return value. Return val. Because we're parsing the given string amount as a double, we could get an error, meaning if we try to parse something that can't be parsed as a double, we're going to get an exception. So let's catch that exception. To do that, we're going to put the following code in a try block. We'll take this code, indent it. This means we're going to try the following code, but we could get an exception. We're going to catch that exception so that our program doesn't crash. So we'll say catch. Specifically, it's a number format exception if we're dealing with a parsing error. Number format exception. We'll call it E. And in this case, we'll just print a friendly message. System.out.println. Let's print the given amount itself, even though it can't be parsed at this point. Can't be parsed as double. So again, we're going to parse the given amount as a double. We're going to call the other eat method with that double. That's this eat method. That's going to return a value. We're going to use that to populate return val, which we've defined up here. And then we're going to return that from the method. If we get an exception at this point when trying to parse the given amount as a double, our code will jump to the catch block, we'll catch the number format exception, and we'll print a friendly message. And we're still going to return val from the method, which at this point will still be initialized at 0.0. Now let's write a method bark that allows a dog to make a given bark sound a given number of times. So it's public, it doesn't return anything, it's called bark, takes two arguments. The first one is the number of times to bark. We'll call it num times. And the second argument is the bark sound that the dog will make. It'll be a string, and we'll call it bark sound. So, dog makes given bark sound given number of times. And we'll say num times to make bark sound to make. What this method actually does is print the given bark sound the given number of times. So let's do that. But first, let's print the dog's name. Print dog's name. This dot name concatenated with a string says, and then we're going to go ahead and iterate over a for loop. For int I equals 0, I is less than the given number of times, increment I, and then we're just going to print the bark sound that number of times. We'll just print bark sound. So this is iterate based on given number of times. And then let's just print one final new line at the end. System.out.println. There we go. Now let's overload the bark method and switch the parameters, meaning if I want to specify the bark sound first, followed by the number of times. Well, we can do that. They're different data types. So still called bark. In this case, let's specify bark sound first, followed by int num times. Here we're overloading the bark method by having the same method name, but by having parameters with different data types. Here we have an int followed by a string. Here we have a string followed by an int. Since both bark methods essentially do the same thing, we're just going to call the first bark method from the second bark method. This is already doing all of the work. So this dot bark, and then we're just going to provide the necessary arguments. Call first bark method with given number of times and given bark sound. So if we decide we want to call the bark method by giving the bark sound followed by the number of times for that bark sound, this method is really just going to call the first bark method here, which accepts the number of times followed by the bark sound. Since these two methods do exactly the same thing, let's go ahead and use the exact same Java doc. Dog makes given bark sound, given number of times, num times to make bark sound to make. Let's overload the bark method one more time, but without any parameters at all. Public void bark, no parameters. Here we're going to force the dog to bark a default number of times given a default bark sound. To do this, we're just going to call one of the other bark methods with some default values. This dot bark will use our static variables. So from the dog class, we have the default num times bark, and also from the dog class, we have the default bark itself. So this is going to call the first bark method here, which accepts the number of times, followed by the bark sound itself. Call first bark method with default number of times and default bark sound. So we'll say dog makes generic bark sound default number of times. I think it's once. Again, this bark method doesn't take any arguments, and it just simply calls the other bark method, the first one here, which accepts the number of times, followed by the bark sound itself, and we're just going to use the default values that are stored in static variables within the dog class, default num times bark and default bark. I'm going to add just a few more methods to the dog class before we actually start using it. The first method is a getWeight method. Public double, it's going to return a double. It's called getWeight. It's a simple getter method which just returns the current weight of the dog. So return this dot weight returns current weight of dog, return weight. And then we're going to have a set name method, which will allow me to set a new name for the dog. So it's a simple setter method. Public void set name with a given name. And this will set new name for dog, name to set. And how are we going to do it? This dot name equals the given name. Now let's create a set owner method, which will allow me to set the dog's owner. So another setter method. Public void set owner with the given owner. So set dog's owner, owner to set. And the way to do this is this dot owner equals the given owner. And finally, one more method. I'm going to implement the toString method, which will tell Java how to represent this dog as a string. Have to define it exactly like this. Public string toString. And I have to return a string representing this dog. So let's return this .name, dog's name, followed by a comma, followed by the dog's weight, followed by another comma, and followed by the dog's age. And let's concatenate the owner of the dog. So this .owner, this will return string representing this dog. So I think we're ready to finally begin creating some dogs. We'll do that in our main method. So we have 3 different options for creating a dog, and that's because we have 3 different constructors. So let's use the first one. We'll say dog1 equals new dog, and we'll use the constructor that takes 4 arguments. So the dog's name, the dog's age, the dog's owner, and the dog's weight. Create dog using first constructor. If we take a look at that here, we could see that the first constructor here takes a name, an age, owner, and a weight. So we're going to create a dog that way. Now let's create a dog using the second constructor, which takes 2 arguments. Dog2 equals new dog, and the arguments for the second constructor are the dog's name, uppercase, and then the dog's age. Create dog using second constructor. If we go ahead and look at that, we can see here we can create a dog with 2 parameters, dog's name and dog's age. And we're doing that here. Now let's create a dog using the third constructor, which takes no arguments. Dog3 equals new dog. Create dog using third constructor. We'll take a look at that here just to make sure we understand. Here's our third constructor, no arguments, and it calls another one of the constructors there in the body. And so here's our third way of creating a dog. Let's just go ahead and print these 3 dogs. Dog1, dog2, dog3, print dogs. And we know that this is going to call the toString method in the dog class. If we take a look at that here, we can see that it's going to return a string with the dog's name, followed by the weight, followed by the age, followed by the owner. So for each of these dogs, it should print those 4 attributes. Let's go ahead and run our program. You could see here it prints all 3 dogs. The first dog is using the values specified in the constructor. So it's the dog's name, it's the dog's given weight, it's the dog's given age, and the dog's given owner. Then the second dog, it's printing the dog's name, but it's using the default value for weight. It's using the given age, and then it's using the default value for owner, which is null, because that's not specified at all in the constructor. And then for the third dog, it's using all default values. So the name of the dog is generic dog. Then we have the generic weight, 1.75, the generic age, and again, the generic owner is null because we never set that in the constructor. So let's go ahead and set a name for dog3. So dog3 dot set name is a method that we wrote. We'll give her a name, Samantha. set new name for dog 3. Now let's go ahead and reprint dog 3. There we go. Let's also put a quick line break here using \n, which is a new line character. Now let's rerun our code. In this case, now dog 3 has the name Samantha, and all of the other values are still default. Now let's call our various eat methods. We'll start by calling the first eat method, which accepts the amount to eat and the specific dog food. So call first eat method. We'll use dog1.eat. We'll say 2.1 is the amount, and the type of food is Beneful. The eat method actually returns the new weight of the dog, so let's go ahead and print that. So call first eat method, print new weight. Let's go ahead and run our program. Before we do that, let's add a blank line here just to clean up the output. Run my program, and I'll see here that Princess is eating the given amount, 2.1, of the given food, Beneful, and that her new weight is this value after eating. It's not rounded. Let's go ahead and call the second eat method. Call second eat method. Let's use dog2. We're going to call eat. The version of this eat method only takes the amount of food to eat, and it's going to force the dog to eat the default generic dog food. Again, the eat method returns the new weight of the dog, so let's go ahead and print that. That returns the new weight. We'll print that. Print new weight. Let's go ahead and run our program. We can see that Fido is eating 1.1 of the generic dog food, and his new weight after eating is 1.761. Well, how does this work? Well, this version of the eat method takes the amount of dog food to eat. If we locate that method in the class, we can see here it takes the amount of dog food to eat. It calls the first version of the eat method with that given amount, and the static variable initialized with the default dog food. It then returns the dog's new weight. We print it. Print new weight. Now let's see what happens when we call the same version of the eat method with an int. Let's use dog3. Dog3.eat. Instead of a double, let's provide an int. Call second eat method with int. And this is going to rely on widening. Then again, we're going to print the new weight. System.out.println. If we run our program, we can see that Samantha is eating 1.0 of generic dog food. And here's her new weight. How does this work? Well, this version of the eat method takes a double by default, but we're passing an int. If we take a look at the method, we can see that eat takes a double, but Java's smart enough to convert the int to a double. So it's going to convert 1 to 1.0. That's called widening. So this is completely legal. Now let's call the third version of the eat method, which takes a string that can be parsed to a double. We'll use dog3. Dog3.eat, and we'll provide a string that can be parsed to a double. So let's say 12.3, but as a string. Call third eat method with string that can be parsed as double. Let's print the result, which is the new weight. Let's run the program, and we can see that Samantha is eating 12.3 of generic dog food, and here's her new weight. So that works as designed. So what exactly is happening here? This version of the eat method takes a string and parses it to a double. Let's take a look. We can look at eat that takes a string, it parses it to a double, and then calls the second version of the eat method with that amount as a double. So this works as designed. Now let's see what happens when we call this same version of the eat method with a string that cannot be parsed as a double. I'm going to copy this comment here. That cannot be parsed as a double. Let's use dog3.eat. If we pass something like the string 12, Java will not be able to parse this as a double. Let's see what happens. Run our code, and we can see that Java prints the following. 12 can't be parsed as double. Let's see how that works. This version of the eat method takes a string. If we look at the method here in our class, we could see that it takes a string, it tries to parse it as a double, it fails because it can't parse that as a double, so it jumps to the catch block, it catches the number format exception, and then it prints a friendly message. The amount can't be parsed as a double, so it works as designed. After calling this version of the eat method with a value that can't be parsed as a double, the dog's weight should be the same as it was before calling the method. So let's go ahead and just get the dog's weight and print it. Dog3.getWeight, and then we'll print this value. System.out.println. Print dog's weight should be the same. Let's go ahead and run our code. We could see that Samantha's weight was 1.883. Then we called the eat method with 12. It couldn't be parsed as a double, meaning Samantha didn't eat anything at all, and her weight is exactly the same, 1.883. This works as designed. Finally, let's call our various bark methods. Call the first bark method. We'll use dog1.bark by providing the number of times the dog should bark and the sound. Woof. Let's run our code. We can see that Princess says woof twice. Now let's call another version of the bark method where we provide the bark sound first and the number of times second. Call the second bark method dog1.bark, and we'll say help me one time. Let's run our code. Princess says help me one time. Finally, let's call the third bark method with no arguments, and the dog will be forced to make a generic bark sound a generic number of times. Dog1 bark, no arguments. Call third bark method. Let's run the code. Princess says bark one time. How does this exactly work? Well, we call the bark method with no arguments. So let's find that method in the class. If we look here, calling bark with no arguments, this calls the first version of the bark method with the default number of times, which is 1, and the default bark. Finally, let's just clean up our code. Let's develop a customer tracking application that keeps track of customers of a particular company. So let's create a new project. We'll call it customer tracking. Now let's create a class. The first class I'm going to create is the customer class itself. Customer, going to need a main method. This will represent a customer with name, ID, and geography. We'll start by creating some static variables inside of the customer class. These will be shared across all instances of a customer. Every customer will have the same value for these variables. So static variables shared across all instances of customer. The first static variable is going to be the name of the company for all customers. So it's static, it's also final, it's a string, and it's called company. And we're going to set it to CVS. It's static, which means it's the same for all customers. It's final, which means I can't change it in my code. It's a string, and it's called company, all caps, used for best practices with static variables. Company for all customers. All customers have the same value for this static variable company. The next static variable in the customer class is going to be an array list to store all customers. It's static, and it's an array list of customers. We'll call it customers equals new array list of customers. Again, this will store list of all customers. And we'll import array list from java.util. And again, because this is static, this list of customers will be shared across every instance of customer. The final static variable in the customer class is going to be an instance of the counter class to generate and keep track of customer IDs. So static counter, and we'll call it counter. Again, all uppercase, best practices for static variables. So this is to generate and keep track of customer IDs. This has no idea what the counter class is because we haven't created it yet. So let's go ahead and quickly do that. Create class counter. Uncheck this. Click finish. There's our counter class. So this now resolves. Now let's create our instance variables for the customer class. Every customer will have a name. Name of customer. Every customer will have a geography. And every customer will have an ID. It'll be an int. Since these are instance variables, every instance of customer can have a different value for name, geography, or ID. Since these are static variables, every customer will have the same company, access to the same list of customers, and access to the same instance of the counter. Now let's implement our counter class. Let's add our instance variables for the counter. Our counter will have an internal count. We'll store it as an instance variable of type int. We'll call it count. Internal count for counter. So let's create a constructor for our counter class. Public counter. When we create a new instance of the counter class, will allow for providing an initial count. And then we'll just set the internal count to be the value of the given initial count, creates counter with given initial count to start with. Now let's create some methods for manipulating the count. Methods. First method will be increment. Public void increment. This will just increment the internal count. This dot count plus plus increments the internal count by 1. And then we'll have a get count method, which will return the value of the internal count. Public int get count. And this will just return this dot count. Returns the internal count, return count. And then finally a way to set the count. Public void set count, given some count. This dot count equals the given count. Sets the internal count to given count. Count to set. And since we have this method here, we should probably use it up here in our constructor. We'll say this dot set count with an argument of the initial count. Call set count with given initial count. Now let's go back to the customer class and create a constructor. So public customer. When we create a customer, we can provide a name and a geography. String name, string geography. Let's set the values of the instance variables. This dot name equals the given name, and this dot geography equals the given geography. The next thing we want to do is generate a unique ID for this customer in the constructor. So when we create a new customer, we set the name, we set the geography, and then we create a new ID for the customer. So this dot ID equals, to generate a new ID, we're going to call the getCount method in the counter class. The counter class, or a reference to the counter class, is a static variable inside of this customer class. So to reference that, we use the class name customer.counter.getCount. So get unique ID from counter. Then to make sure that the next customer gets a different ID, we're going to get the count, and then we're going to increment the count. To reference the counter object, which is a static variable, let's use the customer class name dot counter dot increment. So increment counter. Finally, let's add this customer to the list of all customers, which is a static variable inside of the customer class. So customer dot customers dot add this. This is a reference to this customer. Adds this customer to list of all customers. Now let's add a method for printing all the customers. Methods. Since I'm going to be accessing a static variable, this here, the list of all customers, I'm going to write a static method. Public static void print all customers. And I'm going to iterate over the static variable customers and print each customer. So first, let's print an intro. System.out.println all customers. And then let's iterate over the list of customers. So for each customer C in customer dot customers. Remember, customers is a static variable. We're going to print each customer. So iterate over statically referenced list of customers. Then we'll print one additional new line. Prints all customers for the company. Next, I want to implement the equals method so that I can compare customers for equality. To implement equals, I have to define it exactly like this. Public Boolean equals. Parameter will be an object. We'll call it obj, and I'll have to cast it to the right type. We're going to compare customers by comparing their names and their geographies. If they're the same, then we'll say that the customers are equal. So let's first cast the given object to a customer. Customer, other customer equals. So we're going to cast the given object. Cast object to customer. And then we can compare this customer and the other customer. So if this dot name, if the name of this customer is equal to the name of the other customer dot name, and this dot geography, the geography of this customer is equal to the other customer's geography, equals other customer dot geography. If that's all the case, then return true. Otherwise, return false. And just to be consistent, let's add parentheses around this condition. So this compares two customers for equality. If they have the same name and geography, they are equal. I also want to implement the toString method, which will tell Java how to cast an instance of the customer class to a string. So I have to define the method exactly like this. Public string toString, and of course I have to return a string. In this case, I'm going to return the customer ID, name, company, and geography. So we'll return this.id concatenated with this.name. Then we'll add the company name. Of course, this is a static variable, so it's customer.company, and then the location or the geography. We'll call it location this.geography. And so if we try to print a customer, this returns the ID, name of customer, and geography. Now let's add a method for locating a particular customer in the list of all customers. Since the list of customers is stored in a static variable, and I'm going to be reading from that list, I'm going to make this method static as well. Public static. It's going to return an int, find customer, and I'm going to provide a given customer to find in the list. This locates the given customer in the list of customers. Parameter customer is customer to look up, and it's going to return the index of the given customer in the list, otherwise -1, if it can't find the customer in the list. The first thing we're going to do is set a default index to return from this method. Set default index int index equals -1. And by default, let's return index from the method, and then hopefully we can locate the given customer in the list and update this index. What I'm going to do is iterate over the list of all customers and compare the given customer to each customer in the list until I can identify the index position of the customer in the list. So let's iterate over customer list and locate given customer. Do it with a for loop. For int I equals 0. I is less than customers.size. Increment I. Then we'll compare each customer at index I to the given customer to see if they're equal. If customer.customers.get the customer at index I, see if it's equal to the given customer, in which case, if they're equal, we have the index. We can set the variable index to the index I, and then we can break out of the loop. And here we're going to return index. So we've located the index of the given customer. Here we're comparing two customers to see if they're equal, so it's going to call the equals method in the customer class, which we've implemented here. This compares two customers based on their name and their geography. If they're the same, the two customers are considered equal, so this will call equals method in customer class. If the two customers are equal, then we'll be able to capture the index of the customer in the list, and then we return it. So here in this method, we're able to locate a customer in the list. I want to write one more method that will allow us to remove a customer from the list. Since we're only going to be dealing with a static list of customers, let's go ahead and make this method static as well. Public static. It's not going to return anything, so void remove customer. Which customer? The given customer. In order to remove a customer from the list of customers, we need to first find the customer in the list. So let's do that with the given customer. And we're going to leverage the find customer method, which will return the index of the customer in the list. It's a static method. We'll use the class name customer.find customer. Which one? The given one. That will return the index. Remove index. We'll store that in a variable. And here we're going to find the customer. Since the find customer method will return -1 if it can't find a particular customer, let's make sure that the index returned from the method is not -1 before we try to remove a customer that doesn't exist. So if remove index is greater than or equal to 0, then let's remove the customer. So customer.customers.remove the given remove index. Here is check if index is valid, then remove customer. Removes the given customer from list of customers, customer to remove. Now let's put all the pieces together inside of our main method and start to create some customers. In order to create customers, we have to make sure we have an instance of the counter class so that we can generate unique IDs for each customer. So let's go ahead and initialize the static variable counter in the customer class. Customer.counter equals new instance of the counter class with an initial count of 1. Initialize the counter for generating unique IDs for each customer. Let's go ahead and create our first customer. Create customer. Customer C1 equals new customer Chenyun is the name, and geography is Los Angeles. Creating this customer calls the customer constructor. If we take a look at that in our customer class, we can see that the constructor gets a count from the counter class, sets the ID of this customer, increments the count in the counter class for the next customer, and then adds this customer to the list of all customers. So at this point, after creating our first customer, we should be able to print the list of all customers. So let's go ahead and do that. Print all customers. Customer dot print all customers. Let's go ahead and run our code. This prints all customers. The first customer has an ID of 1. His name is Chenyun. His company is CVS. And his location is Los Angeles. This method, print all customers, prints each customer in the list, and that, in turn, calls the toString method in the customer class, which returns the ID, name, company, and geography, which is why we see that printed here. Let's go ahead and create another customer. Create customer. We'll call this customer C2. The name is Wheeze. Geography is New York City. And then let's print the customers again. So we'll print them twice. Run the code. We can see that the first time it prints all customers, we have 1 customer. And then the next time it prints all customers in the list, we have 2 customers. First customer has ID 1. Second customer has ID 2. Let's create a third customer. Create customer. We'll call this customer C3. Name is Jeffrey. Geography is Australia. And then we'll print the customers again. Let's run our code. First time it prints the customers, we have 1 customer. The second time it prints the customers, we have 2 customers. The third time it prints the customers, we have all 3 customers. Note the unique IDs. Now let's remove a customer from the list. Remove customer. We'll remove C1. Customer dot remove customer. C1, and then finally let's print our list one last time to confirm that that customer has been removed. Let's run our code. We can see that the second to last time we printed the list, all 3 customers are there, and then when we print the list the last time, customer 1 has been removed. The remove customer method takes a particular customer and removes it from the list. It does that by first looking up the customer in the find customer method. It uses the equals method, which is defined in our customer class. If 2 customers have the same name and same geography, they're considered to be equal customers. And in our case, we tried to remove C1, who was Chenyun from Los Angeles, from the list. Let's write a program that will represent an actual classroom with ways of adding students and assigning seats. We'll have 3 classes. The classroom class will represent the classroom itself, containing seats and students. The seat class will represent a seat in the classroom, and the student class will represent a student assigned to the classroom and sitting in a seat. Let's create a new project. We'll call it Classroom Project. let's create a new class, which will be our classroom class in the source folder. File, new, class. We'll call it classroom. I'm going to need the main method in this class. Add a Java doc. Represents a classroom with students. Each classroom has a list of students and an array that represents the seats in the classroom. Let's add some instance variables to the classroom. We're going to have the name of the building, name of building. We're going to have the name of the classroom, name of classroom. Next, we'll have the list of students in the classroom. This will be represented with an array list. Array list of type student, which is a class we haven't created yet, and we'll call it students. List of students in the classroom. I first have to import array list. Import array list from java.util. There we go. Then I have to create a student class. So this resolves. Create class student. Student. Uncheck this. Click finish. There's my student class. So this resolves. Then I'm going to have the seats in the classroom, which will be represented by a two-dimensional array of seats. Of type seat, two-dimensional array. We'll call it seats. Seats in the classroom. Have to create the class seat. Create class seat. Seat. Uncheck this. Click finish. Now this resolves. Next, we're going to create the constructor. Public classroom. It's going to take 4 arguments. The first one is the building name. Next one is the room name. Then we're going to have the number of rows of seats and the number of columns of seats. So this constructor creates a classroom with given building name, room name, number of rows of seats, and number of columns of seats. Building name, name of building, room name, name of room, rows for seats, columns for seats. First thing we're going to do in the constructor is set the building name instance variable and the room name instance variable based on the given building name and room name in the constructor. So set building name, this dot building name equals the given building name, and then set room name, this dot room name equals the given room name. Then we're going to initialize the two-dimensional array of seats with the given number of rows and columns. Initialize seats array. This dot seats equals new seat, given number of rows, given number of columns. And then let's populate the two-dimensional array of seats with instances of seat. Populate seats array with instances of seat class. And to do this, we'll start by iterating over the rows. So iterate over rows. So for int I equals 0, I is less than rows, increment I. Then inside of that, we're going to iterate over the columns in each row. Iterate over columns. For int j equals 0, j is less than the given number of columns, increment j. Then we're going to give each location in the two-dimensional array its own new instance of seat. So seats I, j equals new seat. Give each location its own new instance of seat class. At this point, let's transition over to the seat class to build it out a little bit, provide it with instance variables and a constructor. So seat represents a seat in a classroom. Each seat has a row and column associated with it, and it also might have a student assigned to it. Could have an empty seat. Every seat will have 3 instance variables. The first will be the row associated with the seat. Seat row. Then we'll have the column associated with the seat. Seat column. And then we're going to have the student that's assigned to this seat. So of type student, student in seat. So student assigned to this seat, otherwise null. Let's create our constructor. Public seat. When we create a seat, we're going to provide it with the row and column of its location in the classroom. Int row, int column. Creates a seat for a class at the given row and column. Row for seat, column for seat. Then we'll set our instance variables based on the given row and column. This dot row equals the given row. This dot column equals the given column. So every seat will know its current location in the classroom. Let's create a method for putting a student in the seat. Public void put student in seat. We'll take some given student, put that student in the seat by assigning it to this dot student in seat will be set to the given student. Assigns the given student to this seat, student to assign. Now let's define a toString method, which will tell Java what to print if we try to print an instance of the seat class. So it has to be defined exactly like this. Public string toString, and of course it has to return a string. The string that we're going to return is going to be the row of the seat concatenated with the column of the seat concatenated with the student in that seat. Student in seat. This will also call the toString method in the student class. Because this toString method is concatenating a string version of student in seat, which is an instance of the student class, it's going to call the toString method in that class. We'll look at that in a bit. So returns the row, column, and student for this seat. Since we're talking about a student being assigned to a seat, let's go ahead and implement the student class. Student represents a student in the class. Each student has a name and ID. So for instance variables, every student will have a name, name of student, and every student will have an ID, ID of student. Let's add the constructor for creating a student. Every student will be given a name and an ID upon creation. String name, string ID. Creates a student with the given name and ID. Name of student, ID for student. And we'll set the values of the instance variables in the student class. This dot name equals the given name. This dot ID equals the given ID. Now let's write a toString method which will tell Java how to represent a student as a string. We have to define this method exactly. Public string toString. The string we're going to return is the name of the student. Returns name of student. This method will be helpful if and when we want to print a student. Now let's get back to our implementation of the classroom class. Since we created a constructor in the seat class that now takes two arguments, the row of the seat and the column of the seat, we have to update our code where we call the constructor and create an instance of seat. So we're going to pass to the constructor I and j, which is the row and column for that seat. So given I, which is the row, and j, which is the column, location in the array. The last thing we want to do in the constructor for the classroom is initialize the array list for students. So this dot students equals new array list of type student. Initialize list of students. Next, we want to provide some methods for adding students to the class and assigning students to a seat. So let's start with adding a student to the class. This one's pretty easy. Public void add a student. It's going to take a given student and add it to the list of students. This dot students dot add the given student. Adds the given student to list of students. Student to add. Now let's write a method to assign a student to an available seat in the class. public void assign student to seat given a student finds an available seat and assigns to the given student to assign. What we want to do is iterate over the array of seats until we find an available seat and then put the given student in that seat. I'm going to start by defining some variables that I can use in my iteration. Int rows will be set to the length of the seats array. So this is the number of rows. This dot seats dot length. And then int columns will be set to the length of the first row of seats. So that's the number of columns. This dot seats. Let's just get the first row and then get the length. So gets the number of rows of seats, gets the number of columns of seats. And note, I could have used any row from the seats array to get the number of columns, but I decided to use the first row, so seats using index 0, and then I get the length of that. That's the number of columns in the first row, and it's the same number of columns in every row. Now let's iterate over the rows and columns of seats and visit each seat. So let's iterate over the rows and columns. We'll start with the rows. For int I equals 0, I is less than the number of rows, increment I, and then we'll iterate over the columns for each row. For int j equals 0, j is less than the number of columns, increment j. Then we'll get the seat in that location and see if it's available by checking to see if there's a student in that seat. Get seat in location and see if it's available by checking if there is a student in the seat. So if this dot seats given I j dot student in seat, we'll check to see if it's null. If the seat is null, if null, no student has been assigned to it. And why is that? If we look at the seat class and we look at the student in seat instance variable, this is going to be null until it's set with an actual student. If it's null, we can assume it's available and we can assign the given student. This dot seats in location I j dot put student in seat, the given student. At this point, this method is done, meaning we found an available seat and we put a student in that seat. So we can exit this method entirely. To do that, let's exit the loop and exit the method all at once. Return. Using just this return statement exits the loop and the method all at once. Exit loop and method all at once. Now we're going to write some methods that will show me some information about this class. Let's clean up my code. The next method will be print all students. Public void print all students. So this will print all students in the classroom. How am I going to do that? I'm just going to iterate over the list of students and print each one. So we'll start with system.out.println students in class, colon. And then we're going to iterate over the list of students using an enhanced for loop, and then just print each student. For each student in this dot students, print each one, system dot out dot print line student. By printing the student, it's going to call the toString method in the student class, which we've defined. ToString, this will return the name of the student. So by printing the student, we're going to be printing the student's name. This will call the toString method in the student class. Now I want to define a toString method in the classroom class itself. This way I can just print an entire classroom. So I have to define toString exactly like this. Public string toString, and of course I have to return a string. I'm going to start by creating a string that I can concatenate to. String s equals one single new line character. Eventually, I'm going to return this string from this method, but somewhere in here, let's concatenate to it. I'm going to iterate over the seats array, the rows and columns, and concatenate the seat in each location. I'm actually going to borrow some code from this method up here. This iterates over the seats array. I'm going to do the same thing here. Define the rows, define the columns, iterate over the rows and columns of the seats array. And then I'm going to concatenate to my string this dot seats in location I, J. I'm actually concatenating the seat itself, and I'll add a tab character after that. Since I'm concatenating the seat itself, it's going to call the toString method in the seat class, which I've defined. The toString method in the seat class will return the row concatenated to the column, concatenated to the student in that seat. So calls the toString method in the seat class, and then at the end of every row, let's add another new line character, \n. This ultimately creates a string where the seats in each row are separated by a tab character, and we create a new line or a carriage return at the end of each row. Adds new line at end of each row. Now I'm going to use these classes by writing code in the main method. Let's clean up all of our white space. First thing I'm going to do is create a classroom. Classroom, we'll call it Huntsman, equals new classroom. What's the building name? Huntsman Hall. What's the room name, or number in this case? 105. How many rows of seats? 10. How many columns of seats? 5. Create classroom. Now let's create some students to add to the classroom. Create students. Student Finnegan equals new student. Name is Finnegan. ID is Finnegan W. Then we'll create a student. Bob equals new student. Name is Bob. ID is Roberts. Now let's add the students to the classroom. Add students to classroom. Huntsman dot add a student. We'll add Finnegan. And then Huntsman will add a student, Bob. And then let's assign the students to seats. Huntsman dot assign student to seat. Again, Finnegan. Copy that, paste it here, assign student to seat. Bob. Assign students to seats. Now let's print the list of all students in the class. Print list of all students in class. Huntsman dot print all students. Finally, let's print the classroom itself. print classroom itself, system.out.println, and we're going to print Huntsman. This will show us a layout of the classroom, and this will also call the toString method in the classroom class. We've defined the toString method here. This returns the layout of the classroom with seat and student information. Returns layout of classroom with seat and student info. And now let's run our program. You'll see the complete printout in the console. Let me expand this. We'll see at the top the students in the class have been printed, Finnegan and Bob, and then below that we'll see the layout of the classroom itself. Each row contains seats. You'll see the location of each seat, the row and column number, and then for any seat that's occupied, you'll see the student's name. As an example, let's look at a trivial counter class. The class will declare a counter as an int and initialize it to 0. The increment method will add 1 to the counter and return the new value, and the decrement method will subtract 1 from the counter and return the new value. A good approach is to write the program method stubs first and let Eclipse generate the test method stubs for us. Don't be alarmed if, in this simple example, the JUnit tests are more code than the class itself. Here's our example counter class, public class counter. We have an instance variable declared as count, initialized to 0. Then we have an increment method, which adds 1 to the count. We have a decrement method, which subtracts 1 from count. And we have a getCount method, which just returns the current value of count. Is JUnit testing overkill for this little class? Doesn't matter. Writing JUnit tests for trivial classes is no big deal. Note, you often won't write tests for simple getter methods like getCount. Here's our example JUnit tests for the counter class. Public class counter test. First, we declare a counter for testing. Then we have the setup method, which is annotated by @BeforeEach. This runs before each unit test method. Each unit test method is annotated by @test and begins with a brand new counter. The methods contain individual test cases using assert statements. Note, you can't be concerned with the order in which unit test methods run. For our example, let's implement the counter class and then write JUnit tests to test the methods in our program. So let's start by creating a new project in Eclipse. File, New, Java Project. We'll call this Counter Project. Click Next. Uncheck Create Module Info.java file. And then click Finish. Now let's create the counter class. File, New, Class. We'll name the class Counter. I'm not going to need a main method because I'm going to call all the methods directly from my JUnit tests. So I'm going to click Finish. That creates my class file. Now let's add a Java doc describing the class. /** return represents a counter with methods. We'll start by adding our instance variables. Instance variables. The only instance variable this class will have is the internal count. We'll call it count, of type int count stores internal count. Now let's add some methods. Methods. The first method I'm going to add is called increment, and it's going to increment the internal count. public int increment. It's going to take the internal count, so this dot count, and add 1. And it's also going to return the new value of the internal count. Return this dot count. Add a Java doc. Increments internal count and returns new value of internal count. Our next method is going to be called decrement, and it's just going to decrement the internal count. So public int decrement, take the internal count, subtract 1, and then return the new value of the internal count. Return this dot count. Add a Java doc. Decrements internal count and returns the new value of internal count. The only method I'm going to have is called getCount, and that's just going to return the current value of the count. Public int getCount, return this dot count. Add our Java doc, returns the current value of count. The count. Now I'm going to create the JUnit tests to test these methods to make sure they're working as expected. So let's go to File, New, JUnit test case. We're going to use the default name, counter test, and I'm going to add the setup method, click Next, and then select the methods that I want to test. Increment, decrement, create tasks for generated test methods, then click Finish. I need to make sure that I add the JUnit 5 library to the build path. Click OK, and we're ready to start writing our unit tests. So Eclipse created our new JUnit test class in the same location as the class file that we want to test, the counter class. I could see that the test method stubs are ready to be implemented, as the code in each test method is calling fail with a message to force the test methods to initially fail. If I run my tests, they should all fail. Eclipse will open the JUnit panel on the left. The top bar will show red because my tests failed, and the number next to failures will show 2 because 2 test methods failed. The message at the bottom will explain why the tests failed. Now let's implement the test methods. We'll start by declaring a counter object for testing. I'll do that here as an instance variable. Of type counter, we'll call it counter. Declare counter for testing. Now remember, the setup method, because of the before each annotation, will run before each and every unit test method. So in the setup method, I'm going to initialize my counter, so I have a brand new counter before every test method. So this dot counter equals new counter, initialize counter before every test method. I'll first test my increment method. To do that, I'm going to add individual test cases to my test method. My first test case will use the assert method assert true, and I'm going to assert that calling the increment method returns 1. So assert true. For the counter object, I'm going to call the increment method, and I'm going to expect it to return 1. Why is that? Because by default, the internal count here this instance variable count defaults to 0. Defaults to 0 because we haven't initialized it yet. So when I call the increment method, it should increment that value, return the new value, and it should be 1. Next, I'm going to assert that by calling the increment method again, I get 2. Assert true, this dot counter dot increment should return 2. It should increment the value again. So calling increment the first time should return 1. Calling increment again should return 2. Then I'm just going to call increment a third time. This dot counter dot increment. Call increment third time. We're not testing it this time. At this point, we know that count is 3 because we've called increment 3 times. So I'm going to test this a different way. Assert false when I call this dot counter dot get count, and I compare it to 2, I'm going to assert that this is false. And I'm going to add a custom error message if I fail this test. Should not return 2 after calling increment a third time. Calling increment a third time should not return a count of 2. Since we're assuming the count is 3, let's test that. Assert equals, I'm expecting 3 when I call this dot counter dot get count. That should return 3. Expects 3 when calling get count. And one more test. Let's assert that 3 is not equal to calling increment again. So assert not equals 3 when I call this dot counter increment one more time. We would expect that to be 4. Calling increment again should not return 3. Now, if I run my tests again, I can see that at least the test increment method, you see the white check in the green box, this test method is passing all of these test cases. Now let's write test cases for the decrement method. So initially, let's assert that if I call the decrement method the first time, I should get -1 because the counter starts at 0 by default. So assert equals, I'm expecting -1 when I call this dot counter dot decrement. Calling decrement the first time should return -1 because remember, our counter starts at 0 by default, and then when I call decrement the first time, it should subtract 1 and then return the new value. If I call decrement again, it should return -2. Let's test it a different way. Assert true. If I call this dot counter dot decrement, that should be equal to -2. Calling decrement again returns -2. Let's call decrement a third time. This dot counter dot decrement. Call decrement a third time without testing it this time. After calling decrement 3 times, I'm expecting this to be -3, but let's test it in a different way and at least make sure it's not -2. Assert false, If I call this dot counter dot get count and compare it to -2, that should be false. Let's add a custom error message to be displayed if I fail the test. Should not return -2 after calling decrement again. Calling decrement 3 times should not return -2. And finally, let's assert that calling getCount does return -3. Assert true. This dot counter dot getCount should be equal to -3. That should be true. Calling getCount should return -3. If I rerun my tests, they should all pass. Now I see in the JUnit panel, the top bar is green. That means all tests have passed. Next to failures, I see the number 0. And if I expand this, I can see that both test methods have passed all of their test cases. Let's create a banking project. In our project, we'll have 3 classes. A bank class that will represent a bank for managing customers and their bank accounts. A bank account class that will represent a checking or savings bank account for a customer. And a customer class, which will represent an actual customer of a bank. The first thing I'm going to do is create a banking project. So in Eclipse, File, New, Java Project. We'll call it Banking. Click the Next button. I'm going to uncheck the Create Module Info.java file. Finish. Then I'm going to create my first class in the source folder. File, New, Class, Bank. And I want to make sure I check public static void main because I want that method in this class. For a package, I'm going to provide banking. Click Finish. And here's our first class, bank. The first thing I'm going to do in this class is add a Java doc. /** return represents a bank for managing customers and their bank accounts. In my bank class, I'm going to create a run method. This will serve to run the program by initializing and managing bank accounts and customers. So, public void run. Let me add a Java doc. /** return runs the program by initializing and managing bank accounts and customers. Then, in my main method, I'm going to create an instance of the bank class. So of type bank, call the variable bank equals new bank. This creates a new instance of the bank class. Creates new instance of bank class. Then I'm going to call the run method in the bank class. Bank.run, that's the method I've defined here, calls the run method in the bank class. And then just for fun, let's print something out from within the run method. System.out.println program running. And then if I run my program, Java will first look for the main method, which I've defined here in the bank class. In the main method, I create an instance of the bank class, which is the class I'm in. And then I call the run method in the bank class, which I've defined here. And in the run method, I print program running. Let's try it. Run the program, program running. So far, so good. Now let's create a bank account class. File, new, class. We'll call it bank account. That will be in the source folder. I'm going to use the same package, which is banking, so it'll be in that subdirectory. I don't need a main method in this class because I already have one in the bank class. Finish. Let me add my Java doc, / return, represents a checking or savings bank account for a customer. Now I'm going to define 3 instance variables for the bank account class. Instance vars. So first will be the account type. So of type string, it's called account type. I'm declaring it here. I can add Java docs to instance variables as well as classes. So this is the type of account, either checking or savings. Then I'll create the balance. So of type double, variable called balance. This is the balance for bank account. And then a reference to the customer for this account. So of type customer, we'll call it customer. So this is the customer for this account. Notice I have an error here with customer. If I put my mouse over the red squiggly line, I can see that customer cannot be resolved to a type. And that's because I haven't yet created the customer class. So Java doesn't know what a customer is. So let's go ahead and apply one of the quick fixes. I can create class customer, like that. Opens up the dialog with defaults, same package, banking. And the name of the class is customer. Uncheck this, click finish. Now I have a customer class, and now the customer type resolves. It's important to note that these 3 instance variables can be different for every instance of bank account. They each can have their own account type, their own balance, of course, and their own customer. Moving back over to the customer class, let's go ahead and add a Java doc. Represents a customer of a bank. I'm going to add 2 instance variables to the customer class. Instance vars. Every customer will have a name. String name. Name of customer. And every customer will have an address. String address. Address of customer. So now I'm going to create a constructor for the customer class. So telling Java how I'm going to create a single customer or an instance of the customer class. Constructor. The constructor has to have the same name as the class itself. Public customer. When I create a customer, I'm going to allow for providing a given name. String name. I'll pass that as an argument when I call the constructor. Creates a customer with the given name. And the parameter name is name of customer. And then in my constructor, I'm going to set the value of the instance variable name to be the same as the given name here in the constructor. So this sets instance var name to given name. I'm going to add a few methods to my customer class. The first method is the setAddress method. Public void set address. This takes a given address and sets it to the instance variable address. This dot address equals the given address. Add a Java doc. Sets the address of customer to be given address. Address for customer. This method is defined as public, which means it's accessible outside of the class. Void, which means it doesn't return anything. It's called setAddress, and it takes one argument, a string address. Now we'll define a getName method. This method will return the name of the customer. Public, because it's publicly accessible outside of the class. String, because it's going to return a string. GetName is the name of the method. No arguments, and it's going to return this .name. This refers to the instance of the class, and name refers to the instance variable name. Returns customer's name. Return name of customer. Similarly, I'm going to create a method getAddress, which will return the address of the customer. Public, because it's publicly accessible outside of the class. String, because it's returning a string. GetAddress is the name of the method. No arguments needed. And this will return this dot address. This refers to this instance of the class, and address refers to the instance variable address. Returns customer's address. Return address of customer. Now let's go back to the bank account class and create a constructor there. This will be a way of creating a bank account. So the constructor has to have the same name as the class. Public bank account. We'll set this to be the constructor area of the class. Constructor. When I create a bank account, I'm going to pass as an argument the account type. That's a string. And the customer who owns the account. Customer. Create a bank account of given type for given customer. Account type for bank account. Customer for bank account. In my constructor, I'm going to set the values of the instance variables in the class. So this dot account type will be set to the given account type. And this dot customer will be set to the given customer. Then I'm going to add some methods in my bank account class. These are things that I can do with a bank account. So public void deposit. I can deposit a given amount of money into the account. It'll take a given double and then add it to the balance. So this dot balance, add the given amount. This just deposits the amount by adding it to the instance variable balance. So this deposits the given amount to add to balance. And of course, we're going to have a withdraw method, public void withdraw. This will take a given amount and subtract it from the balance, double amount, and this dot balance minus equals the given amount. The other thing that this method will do is check to see if the given amount is available in the balance. So if the given amount is greater than this dot balance, that means we don't have enough money in our account to support the withdrawal. We're going to throw a new exception with a custom error message. amount is greater than available balance. If the given amount is greater than the available balance, then we'll throw the exception and the method will exit before we subtract the given amount from the balance. But if the given amount is not greater than the available balance, then we'll subtract the given amount from the balance. We're getting an error here because we have to tell Java that this method might throw an exception. So here's the quick fix. Add throws declaration. This says that the public void withdraw method, given this amount, might throw an exception. We'll talk about exceptions a lot more a bit later in this course. So let's add our Java doc. Withdraws the given amount from balance, amount to withdraw, exception if given amount is larger than available balance. Let's add a few more methods to the bank account class. I want to write a method that will return basic account information. So public string get account info. This has to return a string. I'm telling Java that this method will return a string. Return a string made up of the account type concatenated with the balance. This dot account type concatenated with a colon concatenated with this dot balance. Add the Java doc. Returns account type and balance for this bank account. Return string with all the info. I also want to write a method that returns some basic information about the customer associated with this bank account. So public string get customer info. So this has to return a string. I'm going to return a string made up of the customer name concatenated with the customer address. To get the customer name, I'm going to reference the customer instance variable in the bank account class. This dot customer dot get name concatenated with a colon concatenated with this dot customer dot get address. And that's the string I'm going to return from get customer info. Let's add a Java doc. Returns the customer name and address for this bank account. Return string with all of the info. Now let's go back to our bank class and begin creating instances of bank accounts and customers. To create a customer, I'm going to ask the user to enter the customer's name. So we'll start by saying, welcome to the bank. What is your name? To get user input, I'm going to create a scanner. So scanner equals new scanner from the keyboard, which is system.in. Create scanner to get user input. I have to import scanner from java.util. Do that here. And then we'll get the next token or word, which is the customer's name. We're going to use the scanner's next method. Scanner.next next. That gets the next word or the next token as input. And then we're going to store that in a string. We'll call it name. Then let's greet the user. System.out.println hello name exclamation. we are creating checking and savings accounts for you. Then we're going to create a customer using the provided name. So of type customer, create a variable called customer equals new customer. This calls the customer constructor with a provided name as an argument. So create customer with given name. Then let's get the customer's address. So we'll ask the user, get address system.out.println what is your address. Then we'll get the next token or word, which is the customer's address. So scanner.next gets the next token. And we'll store that in a string variable called address. And then we'll set the address on the customer object. So customer.setAddress with the given address. And this will set the customer's address. So now the customer has a name and an address. Now that we have a customer, we can create some bank accounts. So let's start by creating a checking account. So create a checking account for customer. So of type bank account, we'll call it checking account equals new bank account. This calls the bank account constructor. We have to provide two arguments. The first one is a string indicating the account type, checking, and the second argument is a reference to the customer for that bank account. That's the customer we created above. Now I'll create a savings account for the same customer. Copy that, paste that here. We'll call it savings account. Savings account, new bank account. In this case, it's savings. Same customer. Can have multiple accounts for a single customer. Create a savings account for customer. Now let's get the customer info for the checking account. So checking account dot get customer info. That returns a string. I'm going to print it. System.out.println. Okay, so this gets and prints the customer info associated with the checking account. Let's also put a line break here. System.out.println. There's our break. And system.out.println customer info. Now we can run our code. Welcome to the bank. What is your name? Brandon. Hello, Brandon. We are creating checking and savings accounts for you. What is your address? Philly. Customer info. Brandon is the customer name, and Philly is the customer address. So let's change the printout of the customer information slightly. I'm going to go to bank account, look at the get customer info method. Instead of a colon, let's use from. I'll come back here, rerun my code. Welcome to the bank. What is your name? Brandon. Where are you from? Philly. Customer info, Brandon from Philly. Now let's get and print some account information. So system.out.println from the checking account. Let's call get account info. We'll print that. Get and print account info for checking account. We'll say system.out.println System.out.println. This is checking account. Just like that. And then we'll do the same thing for the savings account. Savings account. We're going to call savings account.get account info. Okay, run this. What is your name? Brandon from Philly. Customer info, Brandon from Philly. Checking account, it's checking. The balance is 0.0. Savings account, it's savings, and the balance is 0.0. Now we're going to make some deposits into our accounts. Deposits. We'll start with checking. And we'll ask the user to enter a deposit amount. So let's first system.out.println. Let's just print a blank line. And then let's ask the user system.out.println amount as a decimal to deposit into your checking account. And then we'll get that amount from the scanner object by calling next double, which will get the next token as a double. It'll cast it for us. Double amount equals scanner.nextDouble. So this is get next token. In this case, it should be a double. And then let's actually deposit the amount into the checking account. So checking account dot deposit the given amount, deposit into checking account. And then let's do the same thing for depositing into the savings account. I'm going to copy most of this, paste it down here into savings, print a blank line, ask the user to enter a deposit amount for the savings account. And then we have to use the scanner object to get the next double, which is the next token, casted to a double. We've already declared the variable amount, but I can reuse it here. So amount equals scanner.nextDouble. And then let's actually deposit into the savings account. So savings account dot deposit the given amount. This is deposit into savings account. And once I've deposited into the checking and savings accounts, I'm going to want to see the new balance. So let's print that. System.out.println. We'll print checking account dot get account info, which contains the account balance. We'll do it there for the checking account, and then we'll do it for the savings account. Savings account, print new balances. Now let's run our program. So welcome to the bank. What is your name? Brandon. Philly. So here's my customer info. Here's the checking account information. The balance is 0.0. Savings account information. The balance is 0.0. Now I need to input an amount to deposit into my checking account. So I'm going to put in 175 cents. Amount to deposit into your savings account. I'm going to put 275 cents. Now, here's my updated account information. The checking has $100.75, and the savings has 275 cents. Now let's look at making withdrawals from the accounts. Withdrawals. We'll start with the checking. So from checking, system.out.println blank line. Let's ask the user to enter an amount to withdraw from the checking account. So it's going to be similar to this. Copy this, paste it here, amount to withdraw from your checking account. Then let's actually get the input using the scanner. Scanner.nextDouble. And again, we'll store that in a variable. We can reuse the amount variable. Get next token as a double. And then let's withdraw from the checking account. Checking account dot withdraw the given amount. Withdraw from checking. And it looks like we have an error here. An unhandled exception type exception. If you recall, our withdraw method in the bank account class throws a possible exception, meaning if the given amount is greater than the available balance, we throw an exception. Well, Java's forcing me to handle that exception when I call the method. One way I can handle this exception is by surrounding the code with a try-catch. The way this works is, we'll try to call the withdraw method with the given amount inside of the try block. If the amount is too large, meaning it's greater than the available balance, we'll get the exception and we'll catch it or handle it inside of the catch block. Here, E is a variable that represents the exception. It has a print stack trace method, which by default prints the entire stack trace that led to the error. If you recall, we generated a custom error message when we created the exception and we threw it from the withdraw method. To display that message, instead of e.printStackTrace, we're going to call e.getMessage, which will return the custom message, and then we'll print it. System.out.println e.getMessage. So this prints custom error message from withdraw method. So let's get rid of this. That's our to-do. Let's move this comment here. And then we're going to do this whole thing again when we try to withdraw from the savings account. So from savings, copy all of this, paste it here. From savings, print a blank line, ask the user for an amount to withdraw from your savings account, get the next double, store it in amount, call savings account dot withdraw with the given amount. If we get the exception, we'll catch it here in the block and we'll print the custom error message. So withdraw from savings. Finally, we're going to print out the account balances one more time. So I'm going to copy this from up here and I'll paste it down here. This will print our new balances. Get account info for checking. Get account info for savings. And when we're done with everything, we're going to want to close our scanner. Scanner.close. And then we are at the end of our main method. So we can get rid of all of this white space just to clean up our work. Now let's run the program. What is your name? Brandon. Address, Philly. Amount for checking account, $100, 75 cents. For savings, $200, 75 cents. Enter an amount to withdraw from your checking account, $100. And then enter an amount to withdraw from your savings, $201. So I was able to withdraw from my checking $100. The new balance is 75 cents. Then I tried to withdraw $201 from the savings. I got the custom error message from the exception, amount is greater than available balance, and the balance for my savings account is still $200.75.